It does though. Yeah, Unity dots makes Unity faster. It allows you to make a more efficient game. That's true. But compared to something where you write your own engine, well, let's not talk about ASM, but let's say we talk about C++, it will never be faster than an optimized C++ game because you can't do that in Unity. You have a general purpose engine versus something that is specifically made for a game. So that's why you can never do something like Noita in Unity, or will have a lot of issues doing that in Unity because the engine just doesn't support that. That's why, like, Unity will not be faster than a custom engine. Prove it, Cakez. We will prove it with my game. Yes, Firefly. But let's watch this here. This is Unity dots versus Multithreaded Assembly benchmark. Let's just see how close Unity dots gets. It looks like 180 FPS is running on the left here, with quite a few things happening, but let's see.
I recently made a video comparing the performance of Unity dots and assembly. This is a follow-up to that video, so if you want to know about the background and more details about the benchmark problem, check out the
number of bees, 100,000, running on, I think it's 400 FPS in B combat ASM. So this guy is coding, like, this guy is somewhere on the moon or something with his brain. That's crazy. He's coding in ASM. I guess you can get used to it, but bruh, that's crazy.
Video first. Just click the info card in the top right corner.
Lines. Bruh.
The feedback on that video, at least in the comments, was mostly positive.
That's awesome.
However, I shared the video on Reddit, and there it was a different story. Many were upset that...
You don't go to Reddit for that! There's a bunch of Karens, man. You can't post anything there, man. If you have any comparison ever, there's going to be some programmer that gets offended by your post. That's just the way it is, man. Holy Reddit. Yeah, so dumb idiots, bro. It's always the same. It's funny. And you know, the worst thing is that sometimes it's... Usually we talk about games when we talk about Reddit, and you can't post anything on Reddit because it's just so negative all the time about games and stuff. For programming, it's even worse sometimes because there are some people out there that really think they're smart and they know it all, but they're actually not.
Was not.
And then they get offended so easily.
Faster than assembly. And
so like this chat? Yes! Exactly like this chat, bro. Bonkers.
For problems in the comparison, especially in the dots implementation. Some people were a bit more constructive in the feedback though, and even made their own improvements to it.
Wait.
Some people were a bit more constructive in the feedback though.
Wait.
Problems, and there it was a different story. Many were upset that dots was not faster than assembly, and looked for problems in the comparison.
Many were upset that dots was not faster than assembly. Are they? They don't even know what they're talking. It's insane, man. They're so stupid. Oh my god. Just take a look at one image in RenderDoc and you'll understand why. This is not even rendering. Just a quick look. I don't think you understand the principles behind burst. Oh my god, this guy is so dumb. It's like the first sentence is already making me mad. You're using the MathF library, which is maybe 10 times slower than the Unity mathematics library. You stupid? Oh my god, he read that somewhere on the internet. And so now that is something he knows. If not more, exclamation mark. Bruh.
Especially in the dots implementation.
Burst with inline will inline and generate the most efficient instructions for all the Unity mathematics code. That has absolutely nothing to do with this, but okay.
Some people were a bit more constructive in the feedback though, and even made their own improvements to it. We will look at the improved versions and the performance of them later, but first I just want to discuss the two most common points brought up. The first was the use of the MathF library instead of the units.mathematics in some cases. In the code, the MathF was used for square root and max, and people were saying that it would ruin the optimizations completely. I took a look at the assembly generated and saw that there were nothing bad happening in these cases. It was just translated.
See, this is just something they hear on the internet. And then they're like, oh, but bro, you know what you're talking about. I heard this on the internet. This guy on the internet that sounded really smart, you know. He had a big brain and a big forehead, so there must be a lot of stuff in there. He said it's 10 times faster, and so he's gonna be right. And you're wrong for doing this wrong.
Directly to the sqrtss instruction for the square root, and the max function I could not see any trace of. Its logic probably got baked in some other instruction. The second point was the multi-threading usage in the dots version. I had added sync points in between the jobs since that was the only way I found to get the runtime checks off my back. The reasoning was that since
So sync points are basically points you halt the program and then you validate data. So these sync points could cause or could stall the program to effectively... I'm looking for a PG-friendly word. To... Basically, I don't know a PG-friendly word for this. They could hold the program and generate a longer time than is actually if he didn't do that.
There were so many bees to simulate, this would not matter too much for the final conclusions in the end. I'll let you be the judge of that after we have looked at the results of the improved versions. So let's take a look at the first improved version. This was made by YNDC as a pull request to the repository, and it has since been merged to the main branch.
Okay.
I'll leave a link to the pull request in the description for anyone.
My 30 seconds frame benches. Old dots 6,000. New dots 8,000. So he improved it. That's nice, but it's still twice as slow.
Wanting to look at the details of the changes. In the pull request.
Cakez, how can one possibly debate on it? Unity and any other generic engine is full of shit. Your game will never use that. Will somehow negatively contribute to the game's performance. While an engine written in your own game can be optimized to only consume resources that are strictly necessary. Exactly. That's the point. So let's say you want to move a game object in Unity. You're going to move more data than if I move a game object in my engine, because I can optimize it. I can optimize it down to an X and Y axis. Maybe a couple more data points. But in Unity, you have much more data. The generic solution will always be slower. And I would even argue that, let's say you could do it, you would spend more time in Unity to make that fast than you would spend time in C++. Let's say C++, because I use that, to make it fast. Because Unity has their own way of doing things, and it's rigid in that way. It's not like you can take a transform and take half of the data away from it. I know there's a whole team dedicated to optimizations in Unity, and they need that, but they can never be a specific game. They need to be general purpose. And a general purpose engine cannot make assumptions too much. Yeah, there are a lot of unnecessary renders in Godot, but also in Unity, yeah. They just have...
YNDC made a bullet point list of the changes they made and how it affected the performance. The first change, replacing mathf with unity.mathematics, had no effect. Next, reordered systems by the dependencies and redesigned...
Oh my god! Oh really? It didn't have any effects? Bro! Like, these guys think they know, but they don't, man. Most of these things don't matter when it comes down to it. Like, these are minuscule things. God damn.
An update code to have no sync points. This had a big effect. And the last thing was...
Yeah, the sync points hold the program. That's a problem, yeah. I can see that.
Unnecessary prefab transform hierarchy. This apparently had a surprisingly big effect according to YNDC. And I share the surprise in this one. I would have thought that it is something Unity could optimize for automatically, especially if it has a big effect.
I mean, he's right there, right? You're using sync points, you're doing it wrong. Maybe Unity should be able to have a checkbox burst or whatever, optimized checkbox, and then it optimizes these sync points to be better. I agree with this guy, because that's why you use an engine, right? You don't want to use an option that's bad. Or maybe don't even have this as an option if there's an alternative. The sync points we're talking about were these things here. Where's that? These complete. They're probably using fences. I don't know. Like, I have not used Unity too much, I can tell.
Compared to the original dots version. Here are the results. So all in all, it resulted in a 45% increase in performance compared to the original dots. So a rather significant one, since it is just about using dots better. Still, it is quite a bit slower than the single-threaded assembly version, which is about 82% faster than this improved dots version. But fear not, there was a second improved version made by Thor White Mountain, which further improved the version made by YNDC.
Oh.
It is made as a fork of the repository, so I'll leave a link to it in the description below.
Damn, he did a lot of stuff. Leak detection, safety checks, and jobs debugger turned off. Oh, wow, okay. Leak detection, safety checks, and EST dots twice or something? I am dumb and don't know how to run it. Asm. I would have the same thing, bro. I would say the same thing. Old dots, 4,300. Then he deleted, he turns off checks, which I think you will do that in an optimized build anyways, right? You turn off these checks. That gives us a 30% boost. Turned on? Wait, turned on? Turned off? Huh? I don't understand. The new dots system? Got a build working. Newest dots mono. 7,000 FPS. Remove legacy comp. Dots. I don't understand. Maybe he's explaining it in the video.
And read the full details about the changes and findings they made. I'll just summarize it here.
Yeah?
The changes were mostly about reducing the memory used per entity, especially on the...
I told you. Exactly. The less memory you move around, the faster the program is. Exactly. Yes. And I don't know how far you can go with this in Unity, but by default, you're moving around a lot of enemy, which makes it slow. Exactly. So it's not about the instructions. It never was about the instructions. It is always about the memory. And so you need to do a good job with the memory yourself.
Position data lookups for the movement speed system and attack system. Also removing some structural changes on the entities through the use of special components, such as I-enableable. These changes resulted in an 81% performance increase compared to the original dots. So
now that looks good. That looks really, really good. Now I wonder, this is a single-threaded assembly. I wonder what the point of his video is. He might like, is Unity dots multi-threaded? Will he go multi-threaded and then it's just gonna be like a, we can't even see it on the graph?
The big one. However,
what's happening?
It is still a bit away from the single-threaded assembly version, which is about 46% faster.
Yeah.
So the assembly version is still the winner, even with the improvements for the dots version.
Okay.
But even though it was not needed to beat the improved dots versions, I wanted to see how a multi-threaded assembly version would perform.
Pre-watch, of course. How do you think this will result? Oh, you can't see it. Guys, so multi-threaded assembly. What do you guys think? So basically what's happening here, okay? This is base Goku. Okay? And then this is Super Saiyan. And this is Super Saiyan 2. And even Super Saiyan 2 is not strong enough against base assembly. They didn't even go and try to optimize. Sub 1, I think so too, in minimum. Multi-threaded assembly is black magic. Yeah, this guy is, I don't know, he's on the moon or something. This is, his brain doesn't probably fit in his skull. It's got to be like bigger than normal. 100%. There's a clown in yeah, I'm sorry. Also, why you call me clown? You're banned. Goodbye. You're so lucky. Wait, no. Oh, you're so lucky. There you go. Goodbye. Cringe. Why not go the whole distance and code in binary? No, I think like the point is that C++ can be very close. You can monitor C++ very closely and do something similar, and the results will be similar. While not to the same degree, it will be similar. At least for me. So yeah, this is 2.2.
For this video. The multi-threaded implementation I made is rather simple.
It was 400 before. That's at least 2x minimum. This 3x, more than 3x actually.
And a bit naive, since I did not want to spend too much time on it. I just dedicated an afternoon to it. I specified the number of threads for it to use. In the test I have gone with 16, since my CPU is 8 cores with hyperthreading. The main thread I count as the first thread and then create 15 worker threads.
That's loop. Damn.
Each thread handles a range of bees. So the first thread will take care of bee index 0 to 6249. The second thread bee index 6250 to 12499 and so on.
See, by the way, guys, this is what I was thinking about my game too, right? So, like a small little detour. If I have a game and I have a bunch of structures or a bunch of arrays in the game, let's say we have enemies. That is an array. That's all the enemies in the game, okay? And then we have projectiles. That is also an array. I was thinking, well, how would I optimize this in a multi-threaded version of the game? What could I do to optimize this to make it really fast, if that's what I wanted to do? Because let's say we run into a bottleneck, which we probably are running into a bottleneck at this point, because I didn't optimize the game in 2 years. So we have enemies, we have projectiles, and we have heroes. They all kind of depend on each other, in a way. I could update the heroes first. Break up your loops. Yeah, like I was thinking, I have a thread. And then it only operates, I don't know, on this portion. And then I have another thread here. And he operates on, let's say, the other half. This portion here, something like that. And then the first thread updates these heroes and the second thread updates these heroes. But the problem is, what if a hero accesses another hero from one thread to another? Because they like, let's say this hero here wants to heal the other hero. What about that? So maybe I can't even work. You have a mutex. Yeah, you probably would need a mutex, right? That stalls this thread though. Concurrency in C++, yeah. So that's what I wanted to avoid. You want to put into multi-threaded things, you really don't want talking across threads, yeah. So what I think I could do is projectiles. Though that's the same problem again. Projectiles try to hit enemies. What if I have like a, what is it called? Aufteilung in English? Distribution? 3 threads. And two projectiles of 2 different threads access the same enemy. Is that a problem? Separation, yeah, like, I don't know what it's called in English. Division, distribution, yeah, split, yeah. Just modifying is a problem? Yeah, modifying, aka killing the enemy. Of course. You use parallel for or atomic operations. So we will learn all of this in the future when we get towards early access. Then we will do these optimizations. We'll make the game run faster. Also, I think it might not be an issue. Might not, we'll see. There might be... This might actually be fine. But sturdy posts I do. Like, my game does run quite slowly sometimes. There are pitfalls of the game, for sure. We need to optimize that. It could just be the sort algorithm that I use. Could just be that. We'll figure this out. I know how to do that. We have done this in the past. But that's interesting, right? So I've been thinking about this a lot. Like, we will do this in a couple of months. Just like thinking about it now. No, it won't have race conditions.
Quite good for the CPU cache usage, since each thread then operates on its own sequential part of the memory for each array. I made sync points before the logic update and after the last logic function. This was to keep it simple, even though it's not the most optimal way. For example, it means that the code that calls on DirectX for the rendering and the code that transfers the data to the GPU is not run in parallel with the logic code. In fact, all the worker threads will have to wait for that part before starting their work for the frame.
Oh, I see.
This could be improved by double buffering the data that gets sent to the GPU to allow
That
everything
makes
to
it
run in parallel.
probably almost twice
but for
as
now,
fast.
the simple version will have to do. Maybe I'll make the more optimized version in another video.
Yes.
As I mentioned, I ran the test on 16 threads. I did some tests with different thread counts and started to see rather diminishing returns already after 8 threads.
By the way, an old friend of mine, the number of threads and the number of worker units that you can assign here can have a huge impact on the performance if you do it right. And he wrote a tool that would optimize these numbers in a kernel. It was really cool. And so he could compute the optimal worker and group sizes. It was really nice.
8 threads was almost as fast as 16 threads. This is mostly due to the benchmark becoming GPU bottlenecked on my system at these speeds. I can confirm it by running the benchmark without rendering, which saw a bit larger increase in performance when increasing the thread count above 8, even if not linear. It could also partly depend on there being just 8 physical cores on the CPU, and since each thread is doing the same type of work, the cores might be rather well filled already when running just 8 threads. Let's look at some numbers. The multi-threaded assembly version is about...
You can't see it! Wait. Okay, so you guys still think that Unity will be faster than something that you optimize. And this is not even crazy optimized assembly. And okay, I agree, it's assembly. It's not C++. But you have a lot of options in C++ too. Unity and make a lot... Yeah, people... Like, it's crazy how fast Unity can get. But this is also a very simple example. A game, an actual game, will have a lot more data and it will be a lot more difficult to optimize it. Because you can't just say, oh, I have an array of bees, I update them individually. Almost every entity in a game will have some sort of dependency, and that will make it a little bit more difficult. It's not really that simple than this example. This is just an example of where you can use a lot of concurrency and you can cut a lot of corners with data. So bear that in mind. But it's still crazy.
393%.
Low-level languages would not be too far from assembly. Yes, they are not too far because you have a lot of control. The fact that you don't have... Well, I don't know how much control Unity gives you over memory. But you have more control than Unity.
Faster than the single-threaded one. And it is about 572% faster than the improved DOTS version.
500 times faster? What? I just tested out of suspicion I had, since I used a similar solution for my game, but at a lower entity count, so it's relevant for me as well. And it seems like the component lookup performance doesn't scale linearly with the number of bees. The movement system, which uses random array lookups, scales linearly-ish with the number of bees, with around an additional 1.1 ms per 10,000 bees added. Yeah. The attack system, which uses... Oh, attacks? They're attacking each other? Which uses the component lookups, scales non-linearly, where doubling the number of bees makes the time taken worse than double up. Ooh. So it could be that the performance with dots is better than, or at least closer to the assembly performance at lower bee costs. I see. So there might be some more memory lookups that Unity does behind your back that you can't control, which is what I'm saying. And so the less you have that, the less this is probably stalling, right? Is this mutex? Could this be cross-thread synchronization when you're attacking? Attack system to me sounds like some bees attack itself or attack other bees.
Bee counts for the different versions. Mainly because Thor White Mountain found that the time spent per bee in the moment system and the attack system did not scale linearly with the bee count. It seemed to increase as the bee count increased. So here are the results from the tests. At 1k bees, the overhead in the application rules. Since there's not
1 KB, so it's at the bottom, difficult to see. We can make a screenshot though. I have like a screenshot functionality. We can look at that here. It's really nice. So we can actually see it. So basically, 1 kbs for Unity dots is 0.7, and then ASM is 0.1. And then ASM multi-threaded is actually more because of overhead. And then 10 kbs is 0.9, which, wow, actually nice. And then it's 0.2 in assembly. So this grew more than assembly grew. Assembly grew by 2x. Wait, no, actually, interesting. This actually nice. This one looks good. So wait, interesting. That's really interesting. Multi-threaded is about the same. Then Unity dots 50 kbs, ASM 50 kbs. Yeah, but it's linear. That's why this is so slow. Because you're not utilizing multiple cores. The growth here is the important part. So this is almost 2x. And then from multi-threaded here to multi-threaded here is also almost, is more than 2x. And then 10,000. Okay, so the growth is the growth here is crazy. Hello? Oh wow, 500,000 Bs. Damn. Cool simulation. Now let's see actual gameplays. Yeah. Reddit tiers. Yeah, these are the Reddit tiers here. Yeah.
That much work.
I mean, this is not why you use Unity anyways. Like, you might be optimizing a little bit in a game of Unity, but for the most part, you don't use Unity for the optimization. You use Unity because you want to make a game fast, and that's good. That's what it's used for. That's the good thing.
Due to the overhead being very low in the assembly version, especially in the single-threaded one, it wins greatly over Unity dots. The overhead of the sync points for the multiple threads seem to be larger than the actual work in this case, so the multi-threaded assembly version is actually slower than the single-threaded version. The Unity dots version is much slower than the assembly versions at this B count. Probably due to the overhead of Unity in general, and maybe partly due to thread syncing. But this does not really matter at all in practice, since even Unity is running at around 1300 FPS in this test, and there's no game that needs that kind of update rate anyways.
No, you don't. And you
10
can't do it in a
kbs,
normal
the work
game.
is still probably not enough to outshine the overhead. The multi-threaded assembly is faster than the single-threaded one here, but just barely. So the syncing overhead of the
Unity is not more performant, but Unity is better if you want to make a game quickly, yes, and you can stand working in the editor. Then Unity is better. I said that multiple times. Like, you don't need to listen. I enjoy C++, but hey, if you want to make a game fast, then maybe Unity is a better choice for you, bro. That's of course. Same with Unreal Engine. That's the way this works. But for some people, they just like the C++ route. Big C# got to him. Hello, Ravis, my man. How's it going?
Is still quite large here compared to the actual work.
But it will not be faster.
At least for the assembly version, but maybe for the Unity dots as well. At 50k.
And also, the biggest problem with these engines is, let's not say this happens all the time, but you can have hiccups easier than in C++ because of big memory loads. But then again, that you can also like optimize that away. So it's all of this stuff just depends on how much time you spend looking into it and learning it.
100k.
But it will not be faster.
It seems to be a magic spot where the overhead is not that large compared to the actual work. 100k is a number I used in the previous tests, and I did choose that to have enough work for the benchmark to do, while still being fast enough for the slower Unity versions to be able to run at an interactive frame rate. Here the Unity dots is the closest to the assembly versions. At 50 kbs the Unity dots is at its closest to the multi-threaded assembly version. Below or above that, the multi-threaded assembly version increases its lead. The same goes for the single-threaded assembly versus Unity dots, but at 100 kbs. Lastly, at 500 kbs, we see the scaling problem in the Unity dots solution. It probably scales worse in memory usage than the assembly versions, since I think it still uses more memory per entity than the assembly versions do, even after the improvements. Maybe some more. Yeah,
so this is the problem of Unity. It uses memory that you maybe don't want it to use, but it's just baked into the entity, and there's nothing you can do about it. That could be shaved off,
but I think most of the difference that is left is due to Unity's ECS framework just needing some more memory, since it is a general solution. So to summarize, there definitely was some extra performance left on the table for the dots version.
It would be cool to see a comparison to C++, but I think it will have similar results. Guys, no game will have 500,000 enemies on screen at once, but with a lot of particle systems, you can get very close to a lot of stuff on screen.
It can probably be improved even
And we can say that a B can be close to a particle system here.
further, since that is almost
They are
always the
billions.
case.
If they are billions is one, yeah.
But so could the assembly version. The single-threaded
No
assembly
effects
version
on
is still
particles.
significantly faster than the Unity dots version, and the multi-threaded assembly version is even faster. And remember, this is one specific benchmark, and there are of course a lot of other things that you get.
You know what I find weird? Look at the number of Bs. It says 99,999. Watch this change to 100,000.
With Unity, that probably would make up for the performance difference
Why is it sometimes 99,999?
in most projects.
What's going on here?
But when it comes to creating solutions for a large number of entities, it seems that you will be able to push the numbers higher with a custom solution made in, for example, assembly than you would with Unity dots.
Of course.
I'm hoping to make this a series where I do this benchmark and compare the performance
Dice
between
and battle
assembly
rep.
and other languages and game engines or frameworks.
You should try C and Unity. That would be a great idea. C and Unity. And then maybe C++, modern C++, but that would probably not be that good.
So if you want to see more of that, consider supporting the
And
channel
not
by
rewriting
subscribing.
an assembly.
And also check out my games on Steam, since that is what really will enable me to keep making videos like these.
Hey,
And
Giga
don't forget that
Chat!
C#
Wait, we watched Moose Miners. Oh, that's the guy.
is a script language.
It's the same guy. I see. I didn't know that. I didn't realize. That's Moose Miners guy. We watched the, actually made a YouTube video about this a couple of days ago. This is the video, guys. It's the Moose Miners person, the optimizer. And no wonder he could optimize this game to give an idea who this guy is. Okay, yeah. He can render 1 trillion gems, 64 trillion gems in Raylib and C. That's why this guy's so smart, huh? But let's see, on his latest video,
I recently made a
what is his game? What is he linking here? I saw a different game. Check out Moose Miners Sidestep Legends. Very nice. Sidestep Legends. Ooh, 29 positive reviews. That's nice. All-time peak. No one's playing right now. Ooh. I mean, some people are playing sometimes, but hey, I mean, looks like my game, bro. Yep, looks exactly like my game. Hey guys, that will be my game in a couple of months. How can you render that? Does the GPU have that many transistors? I forgot, but it's mostly about chunking the data up into very, very small pieces and only the data that you need. And then doing instancing a lot, stuff like that. And then for each row, you only store the data of the last crystal and not every crystal in the row, because you're only interested in the last crystal. And so the row could be 1 billion crystals. And then only the last crystal is stored as data, and all of the other ones are instances, which you can compute as well from the count. Stuff like this. You need to think outside the box for that. And the other game, Moose Miners, how's that doing? I think that's doing quite well. 400 mixed reviews. Yeah. Oh wow, 100 people playing. But this is an AFK game, guys. So when you have 400 people, when you have 180 people playing the game, oh wow, it's actually gotten a huge bump here. Maybe because of his YouTube videos too. I don't know. And an update. Cool. Look at that, guys. Game got better over time. Very cool. It's an AFK game though, so how many sales does that really mean? Still, 150 is nice.